Hey y'all, we're here to talk about the last two concepts in Unit 6. Two theorems, the side splitter theorem and the angle bisector theorem. First is the side splitter theorem. And we have this big triangle ABC, and you can see segment DE going through the triangle and intersecting it at point D and point E. These two red arrows, remember, mean that this segment DE and this segment AC are parallel. And so when we have that situation, we have a relationship. So if those two lines are parallel, if those two line segments are parallel, then we have this proportion. And that is that BD over DA. So BD over DA. So those two pieces of that side we make a ratio with. That ratio is equal to BE over EC. So the two pieces of that side. And the way I like to look at it is that we can look at this segment DE as sort of like the fraction bar. So I'm going to have measurements for each of these four segments. If I extend this line, I can almost create a fraction. And that'll be easier to see in the example. So let's check out an example. So I'm telling you that KL is parallel to PN, so let's show that with our arrows. That means we're going to have this relationship formed. I'm going to extend KL on both sides. You might see that we already have these fractions being formed. It looks like 12 over 4 and 9 over x. So we can first write the relationships between the sides. MK over KP equals ML over LN. We'll fill in the values. 12 over 4, just like we have over here, 9 over x. And now all we need to do is solve. So we'll cross multiply, and then we'll keep solving, until we get x is 3. So again, these fractions that we wrote in proportion, if we extend the side splitter segment, we can almost see these fractions being written already. So pause here and try this example. I want you to find the value of x given that KL is parallel to PN. So again, you should always put your information on the picture if it's not there again. KL is parallel to PN. So we have our side splitter. Just like last time, I'm going to extend this side so that I can kind of make my fractions. And I can already see I have x over 12 and 12 over 18. So MK over KP equals ML over LN. And we'll fill in the values there. So x over 12 equals 12 over 18. And then all we need to do is solve this for x. And you should have gotten that x is equal to 8. The angle bisector theorem is kind of similar. If we have an angle bisector, which means we have a line or a segment that cuts an angle in a triangle in half, which we have here. Angle A is cut into two congruent angles. We have another proportional relationship. So we have CD over DB. So the side that the angle bisector intersects is going to be cut into two smaller pieces that we write a ratio. That ratio should be equal to AC over AB. So just like I did for the side splitter theorem, I like to extend my angle bisector. And I kind of end up with fractions again. I have this over this, and this side over this side. So let's do an example. I do have an angle bisector here. P is being bisected. I know that because of these two congruent smaller angles. I'm going to extend my angle bisector. And it looks like I have a fraction here of 10 over 18 and 12 over x. So that's RO over OS and RP over PS. And when we plug in the values, 10 over 18 equals 12 over x. And all we need to do is solve that. We end up with 21.6. So again, it's the pieces of one side form a fraction, and then the other two side lengths form their fraction. And we need to make sure that the numbers that go on top come from the same side of the angle bisector. So notice 10 and 12 both come from this left side of this angle bisector. Go ahead and pause here and try this one. Find the value of y. So I'm going to move my labels out of the way a little bit here. And I'm going to extend my angle bisector so I can see that I have one fraction, 9.6 over 16, and another one, y over 24. I'm just speaking about the side names, the side lengths. That's what that should look like. Again, my two numbers that I put on the tops of my ratios come from the same side of the angle bisector. And when I solve, I get y to be 14.4. So go ahead and try these two problems, one of each for each theorem. Use the examples from the lesson that you just did to help you out. They should be pretty similar, and we'll discuss them in class.